Hi there, good to see you again. What we're going to do in this video is take the limit of this function, which is going to end up being yet another one of our indeterminate forms. So remember, the goal is to rewrite the expression so that L'Hopital's rule can possibly be used. So let's look at the strategy for this one. So as x goes to infinity, we have a variable base and a variable exponent. So this is actually a limit of the form 1 to the infinity, which again doesn't tell us anything just by being 1 to the infinity. We have to analyze this a little more. So remember that the strategy when you have a variable base and a variable exponent is we take the natural log of 1 plus 2 over x to the x and then bring the power down. And that's the whole purpose of taking the natural log, is to bring the power down. So then what we want is the limit as x approaches infinity of the logarithm of the expression. Because remember, we find the limit of the logarithm, we go through the paces, we find our limit, and then the original limit is e to whatever we get. So in this case, we have a infinity, and that is approaching, let's see, natural log of 1 plus 0 is natural log of 1, which is 0. So we have an infinity times 0, which means rewrite using a reciprocal. And here again, we're either going to take the reciprocal of x, which seems easier, versus the reciprocal of the natural log. I'm going to take the reciprocal of x. So this is going to be the limit as x approaches infinity of the natural log of 1 plus 2 over x divided by 1 over x. And just to double check, this still goes to 0, but now 1 over x also goes to 0. We are good to use L'Hopital's rule. So this is equal to the limit as x approaches infinity. Now here's where we have to be careful. Remember that the derivative of 1 over x is negative 1 over x squared. That showed up in a previous video. So when we take the derivative of these expressions, we'll just keep that in mind so we don't have to keep going, writing as the negative power and doing that. You can if you want to. Derivative of natural log of something is 1 over the something times the derivative of the something. So the derivative of 1 plus 2 over x is negative 2 over x squared. And then the derivative of the denominator is negative 1 over x squared. Okay, so that actually majorly helps us here. So this is equal to the limit as x approaches infinity. Now let's just see what happens here. We can multiply by x squared over x squared, and they would just go away. We have a negative over a negative, which makes those positive. So we have 2 over 1 plus 2 over x. And as x goes to infinity, this 2 over x just goes to 0. So now we have the limit of 2 over 1, which we know is just 2. Now that's not the final answer. So remember the original limit, it was the limit as x approaches infinity, 1 plus 2 over x to the x. Since this is the limit of the natural log, that means we have to counteract that by making it a base e. So that limit is e squared. And there we have it.